All right, sketch the graph of each function. Number 1, y is equal to 5 times 2 to the power of x. I'm going to organize my work in the table. Start with -2. If x is -2, 5 times 2 to the power of -2 is 5 times 1 over 2 to the second power, which is 5 times 1 over 4, which is 5 over 4. And that's approximately 1.25. So when x is -2, y is 1.25. So it's about there. Okay. When x is -1, it's 5 times 1 over 2, which is 5 over 2, which is 2.5. So -1 up to 2.5. Okay. When x is 0, 5 times 2 to the 0 power, that's 5 times 1. Anything to the 0 power is equal to 1, which is 5. Alright, when y is 1, 5 times 2 to the first power is 5 times 2, which is 10. And when x is 2, 5 times 2 to the second power is 5 times 4, which is 20. So there's the table of values and the graph. Now let's just connect it with a nice smooth curve. Number 2, again, tables organize the work. Start with -2. 4 times 1/2 to the -2 power. I'm going to use a calculator for that. Make sure you put -2 as the exponent. So that's going to give you 16. So -2 up to 16. Next is -1. 4 times 1/2 to the power of -1. Put that in the calculator. That's going to give you 8. -1, 8. Next is 0. 4 times 1/2 to the 0 power. That's going to be 4. When x is 1, 4 times 1/2 to the first power. That's going to give you 2. When x is 2, 4 times 1/2 to the second power. That's going to give you 1. Okay, so once you have at least 5 points, go ahead and draw a nice curve connecting the dots. Okay. Here, we're going to simplify. Your answer should contain only positive exponents. Number 3. The regular numbers, this 2 and this 3, you can go ahead and multiply those to get 6. Now when you're multiplying numbers with the same base, you add the exponent. So we're going to add this 2 and this 4 for n. So it's going to be n to the 6th power. And then the m squared, we just bring it over since there's nothing to combine it with. And that's your answer. Okay. For number 4, go ahead and multiply the 4s and the 2. 4 times 4 times 2, that's 16 times 2, which is 32. Okay. And then numbers with the same base at the exponent. So we're going to add 3 plus -1 plus 0. That's going to be x to the power of 2. And then the y, since there's nothing to combine it with, you just bring it over. Okay, number 5. Also, this up here was the product. Number 5, we have a power of a power, so we're going to apply the power rule. So when there's an exponent outside the parenthesis, you're going to distribute the exponent to everything inside. Even the 3 has an exponent of 1. So you're going to multiply 4 times those exponents. So 3 to the 4th power, m to the 16th power, and then n to the negative 8th power. Okay. 3 to the 4th power, 3 times 3 is 9, times 3 is 27, times 3 is 81. M to the 16 doesn't change, but n to the negative 8, since it's a negative exponent, you bring it to the bottom. So it's now n to the power of 8 on the bottom. That's your answer. Okay, number 6, similarly, we're going to distribute this negative, so everything that's on the inside. So we're going to have 3 to the negative 4, m to the negative 12, and to the positive 8. Negative 2 times negative 4 is 8. Okay, now we're going to rewrite it. Since we have a negative, all the ones with negative exponents, we're going to bring those to the bottom. So the exponent's going to turn positive. And to the 8th power, that one stays on top. And then you could go ahead and multiply 3 to the 4th, which you did before, which is 81. So n to the 8 over 81 m to the 12. Okay. Next, here we have these fractions. So we have to apply the quotient rule. When you're dividing numbers with the same base, you subtract the exponents. Subtract. Okay, so first, regular numbers, the 3 and the 3, you could go ahead and divide. Since they're the same, they simplify out. Okay. Now for the x's, 0 minus 2, that's negative 2. And then y to the 4th. And then since we have a negative exponent, the x goes to the bottom. So that's number 7. For number 8, the 2, there's nothing to simplify it with, so you just bring it over. For the x, 2 minus negative 4 is going to be positive 6. And then y, 4 minus 1 would be 3. And then that's it. There's no negative exponent, so there's nothing else that you have to do. Okay, 9. Oops. Find the next 3 terms and the 52nd term. Okay, number 9, 37, 47, 57, 67. I could see that this has a common difference of 10. We're adding 10 each time. So the next 3 terms are 77, 87, and 97. Okay. And now for the 52nd term, I need to use the formula. So n is 52, and then the first term is 37. So this is what I'm going to use for the formula. Okay. So this is an arithmetic formula. So make sure you use the correct formula. So a sub n is equal to a sub 1 plus n minus 1 times the common difference. So a sub 52 is equal to 37 plus 52 minus 1 times 10. Okay. And if you use the calculator for this one isn't so difficult to calculate, but you can if you want. So first parentheses 51, 52 minus 1 is 51. And then here, make sure you multiply before you add, or else you're going to get the wrong answer. So it's 37 plus 510. So the 52nd term is 547. Okay. For number 10, negative 34, negative 27, negative 20, negative 13. I could see here that we're adding 7 each time. So the common difference is 7. So the next three terms would be negative 6. And negative 6 plus 7 would be 1. And then plus 7 would be 8. So those are the next three terms. We want to find the 52nd term, and the first term is negative 3. Okay, so this is what we're going to use for our formula, which we're going to use here. This is the one that we're using again, since it's an arithmetic. So a sub 52 is negative 34 plus 52 minus 1 times the common difference of 7. Okay. Now 51 times 7, that's 357, plus negative 34 is 323. So the 52nd term is 323. Okay. Three terms and the 52nd term. All right, 11. Find the next two terms and the eighth term. Okay, so negative 3, negative 15, negative 75. I could see that the common ratio is 5. You're multiplying by 5 each time. So negative 375 times 5 is 1,875. That times 5 is 9,375. And that times 5 is 46,870. So you see that when we multiply, it grows very, very fast. So the common ratio is 5. The first term is negative 3, and the n is going to be 8, since we're going to be looking for the eighth term. Okay, now the formula is a sub n is equal to a sub 1 times r to the power of n minus 1. So this one's geometric. It has its own formula. Okay, so for this problem, a sub 8 is negative 3 times 5 to the power of 8 minus 1. Okay, so the exponent is 7. So 5 to the 7th power times negative 3. It's going to be a big number. So the eighth term is negative 234,375. Okay. And then for number 12, negative 4, 16, negative 64, 256. So we could see that these are being multiplied by -4. Multiplying by negative because you see that it's alternating. So the next number is going to be -1024, and then 4096, and then -16,384. Okay, and now to find the eighth term, we use the formula again. To find the eighth term, we're going to use the first term, -4, times the common ratio, which is also -4. So the first term is -4, and the common ratio is also -4. Okay, and then our exponent is going to be 8 minus 1, or 7. Okay, so I'm going to put that into the calculator. Okay, and that's going to give us 65,536. All right, I think that's it.